Alright, time for the draftphysics.com, debatephysics.com also, but yeah, they won't debate it. They won't argue the arguments, just mush and nonsense. So where we left off, so we're taking a spring, okay, and in this example, stretching it, and the argument is that generally speaking, it obeys a certain law called Hooke's law, which just basically says there's this law of proportionality, amount of energy. It's proving Newton, right, essentially. Energy in, energy out. So it's showing you directly by how much the string stretches, how much energy you've added. So 1 pound looks like this, 2 pounds like this, 3 pounds like that. Again, all these scales aren't using some sort of, magical writing on the scale. Okay, the scale is basically in all the same increments. 1 pound, 2 pounds is twice as much, 3 pounds is 3 times as much. It's showing the linearity. All right, now the surprising part is apparently springs can be over compressed. That is, if you're going to do a stretchy spring thing, the spring can be pre-bent in the stretch condition so that it's actually under compression when it's relaxed. That is, it's all pushing against, the coils are all pushing against each other. And so it needs an extra bit of energy just to get free of the tension already in the spring. So the Gosling character does a video, perfectly demonstrates exactly this point and shows that no, Hooke's law works. And if you take away that is, if you put some a weight on to balance against the compression of the spring, it will obey Hooke's law, generally speaking. So he puts a weight on, and then he doubles the weight, and he gets twice the compression. So he's basically just saying, yeah, exactly what I said. You put a weight on, and it does a certain movement. Now, if you leave that weight on and put a second one on, it does the same movement. It's not harder to compress. It compresses for the second weight just as easily as it compressed for the first weight, demonstrating that, yes, the spring doesn't get harder to push. It's just that obviously, if I was to be pushing it this way, sideways, you'd understand to go 1, then I still have to have a force pushing this way because I don't have gravity anymore. So I can't just put a mass here and say, oh, that's going to make up. No, it's not going to make up. So, I have to add the extra energy to account for 2 mass. And then a 3 mass would be 3 times the energy. But it's only linear, 3 times. 1, unit of force, 1 unit of compression. 2 units of force, 2 units of compression. I mean, it's just so, 1 weight, 1 unit of energy. 2 weights, 2 units of energy, not 4 units of energy. The compression of the spring, twice as compressed, does not make 4 units of energy. He just proved it. And then he does this spiel. So, I mean, I haven't played it, but I'll just play the premise to it. And you're just saying, what an idiot.
He sort of still denies.
Okay, a little bit further back. Of course, I still deny that you're talking anything called reason or rationality. You've just proven that adding an equal amount of weight, the spring is just as easily moved. It doesn't move less. It moves exactly the same when you add exactly the same weight. So the spring being twice as compressed, the second compression wasn't any more difficult than the first compression. It required the same amount of force, the same addition of mass in this case.
The silly business is that Gary sort of still denies that.
So this, again, it's just such nonsense. Denies what? You just proved my point. You just proved me exactly correct. Amazing.
As we extend this spring by force, it requires more force to extend it further.
No, it doesn't. It requires the same exact amount. You just proved it. So he extends it the 1 unit of distance with one mass. He just adds one mass and it extends again a whole unit of distance. He just proved that the second unit of movement was just as easy as the first unit. All you needed was one mass to do it. I mean, amazingly stupid.
Because to most people, that idea seems ridiculous.
No, it doesn't. So we're not even talking about most people. Most people don't even think about this crap. They haven't analyzed it, and the physicists, of course, haven't paid any attention whatsoever, because it's so obviously in conflict with reason. There is not 4 times the energy and twice the compression. Twice the weight is not 4 times the energy. It's ridiculous. 3 times the weight is not 9 times the energy. 4 times the weight is not 16 times the energy. It's nonsense.
Of course you're applying more force.
Oh, well, you have to account, okay? But obviously you just showed you're not applying more force. 1 unit of mass creates 1 unit of force in gravity. You move exactly another unit of distance by just adding 1 unit of force, another mass of the same mass, okay? And it moves the second depth into the spring, the second compression of the spring, and it's equal to the first compression of the spring, demonstrating that it's the same exact amount of work.
What I suppose he's looking at, well, if it requires so much force to get to here, and then you're doubling the force to get to there.
Yeah, same amount of energy. Not quadratic in any way. I mean, Hooke's law demonstrates, again, it's a momentum proof, frankly, not a kinetic energy proof.
I don't know what he means, but it does. Every increment of extension requires a greater force.
So again, it's just nonsense. It doesn't require a greater force to move the distance. The distance just requires you to add the same amount of force. So if you're pulling back the slingshot, it's just as hard to pull back the first unit of distance. Pulling back the second just means that, yes, you still have to deal with the first force. So if I pull the slingshot and hold it, I know I'm putting force. I can feel it. Yes, I have to have a constant force because I'm constantly forcing the rubber bands to be stretched. So yes, I have to constantly apply that force, but the additional force I add is just the same amount as the first force. I'm not going to be adding any more. It doesn't take any more energy to create it, as the weight proves. I mean, just absolutely, again. I put this on the scale. It weighs. I put a second one on. It weighs the same thing. It moves the scale, the second depth of the scale. It's compressing the scale now twice as much. Okay, but it's the same amount of energy to compress it twice as much. It's just 1 unit of energy gets you 1 unit of movement in the scale. Proving, okay, frankly, that it's linear and not quadratic.
Of course it does. I mean,
not in gravity, it doesn't. Again, gravity does the work, right? So look, again, you put this on the scale. I don't have to hold the scale down, right? It's giving you this example. I have to hold it down because this isn't weigh enough, right? Gravity does the work. And then me adding the second one, I'm going to do exactly the same work I did for the first one. And the scale is going to go to 2. And it's going to be just as easy for it to go from 1 to 2 as it was for the scale to go from 0 to 1. Going from 0 to 1 is just as easy as going from 1 to 2. And you just proved it. And then you talk. I mean, you just talk this shit.
we might have to come back to that in another video.
Oh, yeah.
But anyway, I'm glad we cleared that up about Mr. Hook.
Well, all we cleared up was is that now we know that springs can be over compressed. Okay, so because this, all springs aren't alike, and you have to make sure the spring you're using isn't pre-compressed in the sense that it requires a force to relax it, to get it to where the coils aren't hitting each other. So the coils are bent, so they're going to hit onto each other and push constantly on each other, and you have to apply a force to, liberate them from that condition before you can start experimenting with them. So these are obviously springs that aren't ideal for this test. You should use a different spring.
Thanks for watching.
Alright, enough of that crap. Okay, so that's it. I mean, that's all there was there. And it's just too stupid. So I don't know what experiment he's going to try to do. I don't know what his point is. There's no way he's going to demonstrate that twice the compression means I now have 4 times the energy, or 3 times the compression means 9 times the energy, or 4 times the compression is now 16 times the energy. That is, I have 16 times the first force. So if you could move the scale and make the thing fall, maybe I just use the arrow. Alright, so you apply a force and it goes to this. I didn't do that. I was clearly staying right here. I did it again. Bastards. Alright, so this first distance, right, takes a force. And then the second distance, you apply the second force. It's going to be exactly the same force. Third one, same force. You only have 3 units of mass in gravity that create that. That can't create 9 units of pushback. It can only produce 1 unit of pushback, 2 units of pushback, 3 units of pushback. It can only move the 3 mass, the 1 velocity. It can't move 1 mass's 3 velocity. Okay, 3 1 masses or 9 masses 1 velocity. It can't do that. It's only 3 units of energy in. It's only 3 units of energy out. Okay, yeah, there's nothing else to say. I mean, people are just so... I mean, not to admit this physics is a completely underdeveloped, that they never did these preliminary experiments, these elemental, these fundamental experiments, that they have always done this, in the last 150 years, where they extrapolate. They see something and they say, oh, it's a interference pattern. No other way that could happen. Anytime you see on-off pattern, it has to be interference. No, that's not, it's the simplest pattern in the universe. No, it doesn't. And they do it every time. They jump way ahead of what the evidence shows. You do an experiment on silver atoms, and they start talking about electrons spinning. Yeah. What? What? It's just nonsense. Anyway. And they won't admit that this physics is a mess. That this isn't evidenced. You still, again, can't prove the simple premise that 4 pounds dropped 1 foot is the same energy as 1 pound dropped 4 feet. They can do the same work. Now, I'd argue it can if you drop the 1 mass without letting it go at free fall velocity. That is, you allow it to be in the gravity twice as long by allowing it to not free fall and acquire velocity. I can't think of any other way to do it. If you take the free fall height of 4 times the height and you break that down and you say, okay, that's 4 1 units, then you can understand that if I did that, if I made it fall in just 1 second units, it's 4 seconds instead of 2 seconds to free fall. Twice the amount of time. So, but that's the only way you could do it is, let it fall and hit, and then let it fall and hit, let it fall and hit, let it fall and hit. But anyway, let's see. All right. Anyway, till then, I mean, it's just these people are just so dishonest. I mean, it's not big a deal to admit that they should have already done all these experiments, and the fact that the experiments don't exist should bother you people. Should bother you that they'll tell you that a motor spinning 4 times as fast has required 16 times the fuel to spin it 4 times as fast. It should bother you that they're saying these things, that they're saying an 8-pound bowling ball going twice the speed can knock down twice as many pins, that it has twice the energy. You know, half of massive bowling ball, an 8-pound ball versus a 16-pound ball. They shouldn't be able to say this stuff when they have zero evidence. Okay, that's enough. So people are just, they're just so, God, there's just so few people on this planet. They're all just fucking ignorant animals. Chattering monkeys.